Hey, my name is Rob. Welcome to this session on taking control of metrics growth and cardinality, tips for maximizing your observability function. Um, so to tell you a little bit about myself, just briefly, I came from working on distributed systems at Microsoft on Office 365. When I kicked off my career, I then went and did some smaller startups and point of sale. And then after that, I followed, my nose to where reliability problems were a significant source of pain and challenges and needed to be solved with good engineering. Um, so after doing the stint with payment systems and avoiding outages where lots of dollars were collected because of an outage, I went to Uber, where they were obviously faced with very similar problems, however, at a completely different level of scale and growth. And then from there, I started my work on open source, the open source M3 project, which I created, and now I do metrics and monitoring full time, I basically contribute to Open Metrics, the CNCF project, and you can follow along for my thoughts at my Twitter, Roskilly, if you're interested. So, moving on to the agenda. So first, we're going to cover kind of what observability is in the modern world in a cloud-native environment, which obviously there's plenty of other stacks out there and challenges, but we kind of want to hyper focus in on this, and then we want to talk a bit about controlling metrics growth cardinality, which is a massive ongoing systemic problem that the industry is facing, and then look at how you can evaluate how you're doing on all these challenges, and recap the key takeaways. So cloud native observability. Monitoring has obviously come a long way, but there's still some things obviously that at the crux of it stay true, but it's also a pretty complex world, especially with a cloud native stack. Talking a little bit through how I view observability, I think a lot of folks say that, well, if you have metrics, logs, and traces, then you have observability, and it's just about getting better at metrics, logs, and traces. However, of course, I used to think that too, and that's obviously what we did to establish the foundations of being able to observe our dynamic workloads at Uber as we were growing, and then scaling out the container applications that all ran on containers. However, over the years, obviously, I've realized that those are simply the inputs to to what you're doing to deliver observability. And observability really is being able to do three core functions really, really well. So one is knowing what is going on in your system. And that can go from like an extremely high granularity view of things, like a 10,000 foot view of what's happening. And then ideally, you're able to dial that knowledge all the way down to like a single process on a single machine somewhere, processing a single request. And then essentially the next part of the problem is triaging. So, that knowledge is all well and good, but if you can't use that knowledge in an effective way to quickly triage a problem, which is basically, understanding where the impact of an issue actually is, and how to mitigate that issue without actually like fixing a root cause, that's really important. So much like, if a plumber came in and saw a leak that was sprung, he or she would not go and immediately find out the exact valve and the exact type of thread which caused the leak to start occurring. They're going to of course like determine, this is the part of the pipeline that I need to fix, and I'm going to go fix and mitigate that issue before even trying to understand what went wrong here. So triaging is about that step. And obviously, having the 10,000 foot view is really important to being able to do that. And honestly, why I think that metrics has become so popular over the past kind of 5 to 10 years. And then, of course, understanding and root causing the problem is obviously very important as well. But it typically occurs after remediation, when engineers can take the time to locate and understand underlying issues without the pressure of a ticking clock of customer expectations. So, this was an interesting journey at Uber. I wanted to kind of like talk a little bit about some of the challenges that happen there, but that are occurring everywhere across the industry. We started with now US and Graphite, which served us quite well when the service was running was one single application in one single application and offering in 3 cities, with a single monolithic backend and on tens of VMs or physical hosts actually back in the day, and then essentially evolved into us essentially running tens of products in hundreds of cities with hundreds of different microservices on like thousands of VMs. And at that point, we had to do maintenance and expansions constantly. And Graphite just wasn't a great fit there. The lack of replication and the fact that you couldn't do very dynamic queries on the .parse separated nature of the metrics was pretty limiting. So at Uber we used Cassandra and Elasticsearch to be able to continue to expand the ability to horizontally scale out the telemetry data. But then we're using, of course, still like the old Graphite naming convention still, which while it scaled to a few hundred microservices, it started to give this kind of more of a treating things as snowflakes rather than being able to standardize individual metric names and use them across all the different microservices, and standardize on dimensions and labels and tagging your telemetry data. And then, of course, we began open source M3 to actually cost effectively manage that scale out of telemetry data. When something costs 10x less, you can store a lot more in it, and you will use it in entirely different ways than you could before. And that is really what M3 unlocked for us, and the Prometheus data model is what unlocked the ability to really standardize and make that metrics experience work across thousands of microservices. So yeah, by the end of it, we had hundreds of different, slightly different product lines in more than half a thousand cities with thousands of microservices and millions of containers. So I think that what's interesting is that there are other people out there at much smaller scale than that last milestone there, but have the same problem in that things cost them so much because they're storing so much telemetry data, and it's either not cost effective to do that, or it's just really tough to even just manage the inventory of their telemetry data. So I wanted to kind of like talk you through one quick example here, which is explaining at a really basic level what cardinality is and how it impacts the scale of the telemetry data you need to collect. So this is kind of showing a transition between from a non-cloud native environment to a cloud native environment. So in the past, say you're monitoring 10 HTTP endpoints, 5 microservices, and 300 VMs. That's like 150,000 possible unique time series. However, in a cloud native world, when you're running 10x the amount of instances, because you're now using, 100x the number of that, you're now using like 30,000 pods when you would have used only 300 VMs. And then, you frequently are running things like experiments in a cloud native world. And with services like Launch Darkly, that's so much easier to do these days. So when you start to add in some of these variables that a lot of folks are using in a native, in a modern cloud native environment, you start to see that the multiplications on this basic set of telemetry data really start to amp up. And so you can see this multiplier of 100x on the number of instance counts because you're now running them in smaller pods in a Kubernetes cluster or a different kind of compute cluster. And then also like 100x, say, on the different experiments that might be live at any one time being processed by these containers. You end up going from 150,000 possible unique time series to 150 million. And there's a lot of power in that extra level of granularity that is enabled by that expansion of the unique time series you're storing. So it's actually extremely powerful, but obviously we need a next order of cost efficiency as well as ways to inventory and control this data to actually unlock this kind of transition and migration to functioning in a more advanced and higher scale manner. No matter like how big your operation or organization is, these are kind of native multipliers that occur on any kind of workload. And we did see, folks, tracking petabytes of Prometheus telemetry data out there at companies like Monzo and much smaller companies that were younger. So this is definitely a trend that's happening at many companies out there. So, I want to walk through a few different ways in which you can tame data growth and cardinality. So, there's a few things here. One is kind of really establishing when there's too much and not enough data. And so helping people like level set, like how much data is enough and where it's good to actually expand on the granularity and where it's not so good and kind of potentially destructive to spend on cardinality. And then, of course, we're going to talk about how actually managing at a micro level everything is like really tough and difficult, and strategies to combat that, and also looking at the ownership needed to help you achieve your goals. So the first thing we want to look at is giving you solid recommendations on how to reduce the tension between too much and too little data. So first order of magnitude, the first order of business really here is understanding that the magnitude of your data does definitely not translate to how well you are doing monitoring or observability. And so, one of the key takeaways we'll have at the end is telling you a little bit how to do that more holistically. But just remember that the amount of data that you're collecting is not indicative of how well you're doing. What you're trying to do fundamentally with the observability function is model the system and your business in a way into observability and monitoring telemetry data, which humans can understand. And so you're really trying to create a map and a set of telemetry data that lets you really measure things in a way that's critical for humans to be able to get their work done and understand the system and mitigate problems. So that's number one, what the priority should be. How to achieve, I guess, like this, right level of data. There's a few different recommendations we have here. One is, really defining some best practices for your organization. So creating, using, the internal frameworks that you use in your libraries to connect to MySQL, to process gRPC or HTTP traffic. All of those common libraries that your company uses, adding the correct level of granularity on those labels really matters. So for instance, you probably don't want to put in the full HTTP URL when you track like a metric, like when you're using metrics to track a request. You want the HTTP route, not the and that's so that way you don't have dynamic variables leaking into the labels and what you're monitoring. But the most important thing is, once you've defined that in the libraries, also writing up some best practices for your team. So saying like things like user ID should not be recorded for metrics, but are okay for logs. And kind of having that very clear guidance on what belongs where. And there's obviously some great material out there on the internet that can help you guide, like knowing what a specific dimension, whether that should be okay to put into metrics or not, and whether to use that in logs or traces. effectively. And then, of course, you want to find ways to control the data flows. So when people go, well above what their usage pattern is, you want to be able to be able to clamp down in an emergency situation so that their flood of telemetry data doesn't impact others. And then also you want probably to have some alerts and accountability set up here. So you want some visibility saying like, hey, week over week or month over month, your rate of metric emission is more than 2x. And that doesn't, that shouldn't fly. Now, obviously, it's really tough to kind of determine like what's healthy and not healthy here. Each microservice will be doing different things and adding new use cases which they're monitoring. But you can find ways to track it back to business. Like if your overall transaction volume into your data center went only up by 2x, then it's probably healthy to say most teams should have only 2x their telemetry data over that same period of time. So you can start to do some really smart analysis like that to at least give visibility and be able to tap people on the shoulder about what they're doing. And then, of course, managing at a macro level, you have to have obviously good visibility into your own telemetry and monitoring platforms. So having good, what we call, macro level views on how the monitor of the system, the monitoring system itself and the products and platforms you use is doing. So that's, looking at how many unique time series you're tracking, how many samples per second do you collect, what's your overall storage being used, and also, of course, like looking at things like time to availability, like tracking how long it actually takes for telemetry data that you publish to the system to show up. So you want to start to alert on your own uptime, your own availability, your own kind of performance of your telemetry platform. And then, of course, you want to actually start to use things that can help you roll up views of telemetry data across entire categories of like logs and metrics. So this is why downsampling is so important, because you want to define policies that can take effect across your entire fleet of telemetry data. So for instance, with the open source project M3, and obviously, things that use that, I run a platform called Chronosphere. We have the ability to say, I want to take out the pod label for anything that matches this type of metric. And that can help, create step level functions of savings. So thinking about those policies and how to apply those policies, this can also be done, of course, by, relabel rules with Prometheus, dropping certain swaths of metrics right up at the beginning of where you ingress into your telemetry platform. So just think about those, those things you can do as a central observability team that has a multiplier effect on the level of data you're keeping and how it's kept and stored and costs you as an entire organization. And then number three, you really need to have shared ownership spread across the company for your telemetry data. So it's really hard when everybody thinks of this service as a free lunch. Monitoring and observability is what will keep your company able to operate without massive outages or huge levels of impacts when you do have an outage. It's the thing that keeps your system dependable, and it's the reason why people come back time and time again to use your service, right? Because of your high level of reliability, and you can't have that without great observability. So establishing with the leadership that, hey, this is not just some kind of thing that we need to actually run our software. This is like a core competency that drives like better latency and better reliability, literally drives business to your company and builds brand excellence. So that needs to have buy-in from the executive level. And then once you have that kind of level of buy-in, it's about working with engineering managers and other people at your organization to to kind of have a top level agreement on what their metric growth can be, or logging or tracing growth can be, so that not any individual team is going to overwhelm the system, and everyone has an idea of like what is a reasonable level of usage that that they can have given the level of like growth and where given the level of growth and the size of your size of the amount of VMs and just cloud infrastructure you're running in general. Once that's all established, then it's pretty easy because you can meet quarterly and just check in that like everyone's in agreement, both from leadership to the teams, and then that the teams are playing by these rules that you've kind of set up and established with buy-in from leadership. And you have to remember, of course, as well, like here we're also talking about not building if you don't have to. So this means that like instead of instead of you having to do everything, you can find the best kind of either open source projects or vendors that let you go from 0 to 100 in a way that helps you kind of focus on the parts of the problem that you need to focus on, which again, as I said about observability in general, it's about mapping that system that's intangible and nebulous running in your cloud infrastructure into a mind map that humans can understand and can drill down to the level of depth they need to when they need to go deep. So really focusing on what the parts of the system that you can build that adds value to that part of the story, not on like the underlying infrastructure. That it's much better to choose a great vendor or open source projects to make great progress there without reinventing the wheel. And then, of course, encouraging safer experimentation and iteration is really important. So make sure you have a second set of telemetry data where you can perhaps mirror some of the telemetry data from production and experiment on upgrades and changes to your pipeline without impacting your organization's visibility into their production workload. And then finally, I want to talk a little bit very briefly about how to measure the function of observability at your organization. I want to talk a bit broadly about how many full-time engineers do you think you should be, dedicating towards these efforts. Typically, we find that dedicating a few people to really understand the end-to-end problem, and then, but then of course having them leverage, open source tools and projects, good vendors, and kind of like off-the-shelf solutions when and where they exist is the best bet. So typically, at Uber, we started with 2 people kind of part-time of 100 when we had 100 engineers. That's when I joined the company just shortly after that. By the time that, we had a dedicated team, there were 5 full-time engineers and 500. And by that time, we were already kind of doing I would say that's already pretty well past like where most people get to in terms of five dedicated team members is a fair amount. And obviously 500 engineers is a pretty sizable company as well. But you can usually get away with, a handful of dedicated people, and roughly 1 to 2% of the headcount, whether that's part-time in terms of their dedication or ideally full-time. That's kind of where is what we found at Uber was a good sweet spot. And then, of course, how much should you spend in it? At Uber, we grew it to 8%, just the metrics infrastructure. So that's not including logs or tracing. Then we hyper optimized it down to about 3% with extended growth. But using, of course, some of those mechanisms I talked about to make sure that the growth of and cardinality wasn't runaway crazy. But in general, the fact that you're looking at 10 or 10+% on your instrumentation and observability is unsurprising, right? This is some of the most value you'll get from the cost of your cloud infrastructure, because it's not just running the thing; it's being able to run it in a way that gives you great product experience in terms of latency and reliability, and has a strong insurance policy that your company is not going to run into catastrophic issues. So, and then just measuring like how things work, like how your developers at your company think you're doing in providing a rapid development environment that allows them to feel good about the changes they're making and understand the system. Really, internal and external NPS surveys are the best for that. Of course, make sure your SLOs and SLIs on that that view of what you're running yourself or providing to your end users as a observability monitoring platform is important. And then, of course, looking at how your company is doing in terms of the error rate and the speed to mitigate real production issues is obviously something to keep in mind at a meta level to see how you're doing. But that was a lot to cover, so I squeezed it in. Thank you for kind of joining me on that journey. If we have time for questions, we'd love to do those. But the key takeaways, you really should think about how can you easily get notified when something is about to become wrong or is already affecting end users? How quickly can I triage it, know what the impact is? How quickly can I find that underlying root cause after I've mitigated and triaged and stemmed the bleeding of like an active issue? And remember that more data is not better. Know when to deep dive on your metrics and when not to in terms of the level of granularity, and provide best practices for your end users. And up-level your function with automation, safe experimentation environments, and top-down support from leadership. And don't build if you don't have to. It's a marathon, and focus on what's going to drive value for your organization. And with that, I want to say thank you. It was great having the chance to talk to you all, and have a great day.